Okay, part A. Base your answers to questions 1 through 4 on the following diagram. The diagram represents a plastic hemisphere upon which lines have been drawn to show the apparent paths of the sun on 4 days at location in New York State. For instance, New York State. 2 of the days are December 21st and June 21st. The protractor is placed over the north-south line. Number 1. Which 2 dates could the sun have followed the path CC? Alright, first thing I would do is, your lowest angle, A, is December 21st. Your highest angle, D, is June. And you know that B is going to be your equinox, be it March 20th to 21st or September 22nd or 23rd. So if I am C, I'm somewhere in between either March and June or June and September. With that, your answer's got to be 4. May 7th and August 1st. Number 2. Which path was recorded on the day that had 12 hours of daylight and 12 hours darkness? Well, 12 hours daylight and darkness means it's equal, so it's got to be an equinox. So that has to be B prime. Number 3. Which would be the appropriate length of daylight for an observer when the sun travels along the entire length of A prime? Alright, so we know it's got to be less than 12 hours because B prime is an equinox, which is 12 hours daylight and darkness. The only value that's less than 12 hours is number 1, 9 hours. Which observation about the sun's apparent path on June 21st is best supported by the diagram? Alright, so if I'm looking at June 21st, that's the DD prime one. The sunrise occurs north of east, because again, here's sunrise, it is north of east, because east is where B is. Number 5. Which motion causes the apparent rising and setting on the moon each day as seen from a location in New York State? The apparent motion of the moon setting and rising, just like the sun, is due to the Earth's rotation, or the Earth rotating on its axis. Number 6. As Earth revolves in its orbit, from its January position to its July position, the angle between its axis and its orbital plane will going to remain the same. It's always 23.5 degrees is the tilt. In January, the southern hemisphere is tilted towards the sun, and in July, the northern hemisphere is tilted towards the sun, but always 23.5 degrees. Number 7. The following diagram represents Foucault's pendulum in a building in New York State. Points A and A prime are fixed points on the floor. As the pendulum swings for 6 hours, it will, number 1, appear to change position due to the Earth's rotation. This is that video that I recorded for you on the Lazy Susan with the wooden pegs and my keys. The rotation makes it look like it's actually the blocks are being knocked down. Base your answers to questions 8 through 12 on the following diagram. Number 8. Earth will travel from A to B in. So if I'm looking at A, I'm looking at the sun and the moon in respect to each other. So it's going to be a new moon. Then I look at B. For that one, it's not quite a full moon. You're looking at a crescent. So you haven't gotten to that 29.5 days for a complete lunar cycle. You're pretty close though. So it's going to be 27 and a third day. Number 9. In respect to the Earth at position B, in which phase is the moon? As I was saying before, it's a crescent. What I did was I actually drew as the moon would appear here, and then I looked at it. How would it look like to the Earth? Now, remember, I'm over here, the Earth is down here. I'm looking this way. Most of it's dark and just have a little of a sliver that's going to be illuminated, so it's got to be a crescent. Number 10. When Earth is at position B, how long must the moon travel beyond where it is shown to be in the same phase as it was in position A? That's the extra 2.2 days. So 2 days is your answer. Remember, complete lunar cycle is 29.5 days. Number 11. What is the main reason why the moon must travel a greater distance to be in the same phase at position B as it was in position A? And that's because the Earth is constantly revolving around the sun, so it takes that extra little time to catch up. Number 12. At position B, the highest tides on Earth will occur when the moon is at its positions. So I need a high tide, new or full moon, correct? So with that one, I need the moon and the sun being either in the same plane or same angle. So that would be 1 and 3. Number 13. The Coriolis effect provides evidence that the Earth rotates on its axis. Straight out of your notes. 14. A projectile is launched from a point near the North Pole towards the equator. Which diagram best represents the apparent path of the projectile if it was viewed from the Earth? Alright, so I'm looking at this one. Northern hemisphere, they get deflected to the right. So I'm standing on the North Pole. This one is going to get deflected. That would be my left, because remember, I'm here, I'm looking down this way. This one's straight, it's not getting deflected. This one is going to get deflected to the right, so I got to go with answer number 4. 15. Some stars that can be seen in New York State on a summer night cannot be seen on a winter night. This fact is the result of the revolution of the Earth around the sun. Remember, we talked about this one. You stand up, wherever you're looking at right now, they're your summer constellations. Do a 180, your winter constellations. You only see the stars at nights when it's dark. The stars are out there right now, but it's too bright. Number 16. To an observer on Earth, the planet Venus does not appear at a fixed position among the stars because Venus, too, revolves around the sun. It, too, is a planet. You can see the planets also at night. The larger the planet, the more it will be illuminated. Number 17. The diagram below shows the rotation of Earth as it would appear from a satellite over North Pole. The time at point X is closest to. Alright, again, we're at the North Pole. Half of it's illuminated and half of it's dark, so it's equal. So it's got to be an equinox. Knowing that, my point X is rotating into the dark, so it's the sun sets. So with that one, 6 p.m. Alright, coming here would be 6 a.m. is rotating into the light. Halfway in the dark would be midnight. Halfway into the light would be noon. 18. The new moon phase occurs when the moon is positioned between Earth and the sun. However, these positions do not always cause an eclipse of the sun because the answer is going to be number 1. The moon's orbit is tilted relative to the Earth's orbit. They're not perfectly aligned. They're usually off about 5 degrees. Part B. Base your answers to questions 19 through 23 on the following table and the information. So you're looking at 3 dates when they give you the first high tide, the first low tide, second high tide, and the second low tide. The Bay of Fundy, located on the east coast of Canada, has the highest ocean tides in the world. The St. John River enters the Bay of Fundy at the city of St. John, where the river actually reverses direction twice a day at high tides. Data for the famous reversing falls of St. John River are given on high and low tides at June 26 through 28, 1994. Number 19. Which graph best represents the tides recorded on June 28th? So you're looking at what time you have your first high. So you're going to peak up at 4 o'clock in the morning. And your next high tide is about 4:30 in the afternoon. So the one that's going to fit that best is number 1. Number 20. Compared to the first high tide in June 26th, how much later in the day did the first high tide occur on June 27th? So you got to do a little math there. I have 3:15 minus 2:25. It's going to give me 50 minutes. So my answer is 50 minutes. Number 21. Tides in the Bay of Fundy are best described as they're predictable and cyclic. That's why they actually put the times down, and you can go actually see that on your own. 22. Complete the following sentence. The moon has a greater effect on the Earth's ocean tides than the sun has because the The answer is the moon is closer to the Earth, so it has a greater gravitational attraction than the sun. That one, in order to figure out gravitational attraction, you take the mass of object 1 times mass of object 2 divided by the distance squared. Since the distance between the Earth and the moon is a lot smaller, when you square that and then take that larger number at the top and divide it, you have a greater effect. 23. Which model of the sun, Earth, and moon best represents the position that would cause the highest ocean tides in the Bay of Fundy? Alright, that's going to be your spring tides. Spring tides are either new or full moon. So the answer is number 1. 24. On the United States time zone map provided below, indicate the standard time in each time zone when it is 9 a.m. in Central Time Zone. The dashed lines represent the standard time meridians for each time zone. Be sure to indicate the time for all 3 zones. So if I know that it's 9 o'clock in Central, we're an hour ahead, so that would make it 10. And each one is going to be an hour behind. So if it's 9 here, Mountain is going to be 8, Pacific is going to be 7. So 10, 9, 8, 7. Draw and fully label the diagram showing the total eclipse of the sun. Include the label of the shadows, all solar system members shown, and phase of the moon. So you're looking for a solar eclipse. Now, for that one, it's easiest if I go back to page 74. So your solar eclipse, I have sun, the moon, which is a new moon, and the earth. The dark area of your shadow is your umbra, and that fuzzy gray area surrounding that dark area is your penumbra. So if I'm looking at, you have a very small umbra because the moon is so much smaller, and you have a little bit of gray or penumbra on each side of the umbra. Use the information to answer questions 26 through 29. The following diagram represents the apparent path of the sun from an observer in New York State on the dates indicated. The diagram also shows the angle of Polaris above the horizon. On the diagram, draw the apparent path of the sun on May 21st. Well, May 21st, I know it's got to be north of east. I got to be north of east, but I can't be my highest one, which would be June 21st. So I am going to be closer to June than I am to March. So I'm going to put it right where my purple is. Purple line is going to be my May. Come up, solar noon, coming back as my sunset. On the diagram, mark and label the positions of sunrise on May 21st. So my sunrise is going to be right here, where my arrow is. North of east. 28. State the latitude of the location represented by the diagram to the nearest degree. Include the latitude direction in your answer. The way you know your latitude is when we did maps. Remember, your angle to Polaris is the same thing as your latitude in the northern hemisphere. So if my angle to Polaris is 43 degrees, my latitude's got to be 43 degrees north latitude. 29. At approximately what hour a day would the sun be at position shown in the diagram? So if I'm looking at the sun, it's coming down. It's past the solar noon and it's coming down. It hasn't gotten to sunset yet. So with that one, you're looking at approximately 3 p.m. because my sunrise would be at 6 a.m. My sunset would be at 6 p.m. You're halfway from a solar noon to sunset, so around 3 p.m. Part C. Using the following statement, answer the questions 30 through 33. Suppose the Earth does not have or has never had a moon. 30. Why would Earth still have ocean water tides? Well, you still have gravitational pull between the sun and the Earth. So with that one, you would still have some tides. 31. How would Earth's ocean tides be different than they are with the presence of the moon? Your tides are going to be lower than they are currently. Number 32. Would people on Earth experience lunar or solar eclipses, and explain why or why not? you couldn't experience an eclipse because for a solar eclipse, the moon's casting a shadow on the Earth. And for a lunar eclipse, there's nothing for the Earth to cast a shadow on. 33. Infer how the lack of a moon would have affected timekeeping throughout history of humans. What specific time period would have been affected? Well, the moon, the revolution of the moon around the Earth is a month, so we would have no month. Using the following statement, answer questions 34 through 35. Through accurate measurements of time and studies of growth patterns of fossil life forms, it has been determined that the Earth's rate of rotation is slowing down. 34. What unit of time will most altered by this change in the Earth's rotation? Well, the thing that changes with rotation is day. Because remember, a day is how long it takes the Earth to rotate. 35. List two completely different types of apparent motions observed on Earth today that would not exist if the Earth was to stop rotating. Well, if the Earth was to stop rotating, we would not see the sun or the moon moving around us, rising and setting. We would also not have the Coriolis effect or the Foucault's pendulum. 36. The diagram provided below represents the sun and the Earth as viewed from space on a certain date. Using a symbol for the moon of an approximately this size circle, draw the position of the moon on the diagram provided above at the time when the moon is a full moon phase is observed from the Earth. Alright, full moon means it's going to be dark. You have sun, Earth, moon. So your moon is going to be over here because the side facing the sun is always illuminated. Letter B. Draw an arrow on the diagram provided above that shows the motion of the Earth that causes the surface ocean currents and surface winds to curve or the Coriolis effect. You need rotation. Remember, we rotate counterclockwise. 37. The drawing below shows a mile-wide barrier impact crater located in Diablo Canyon, Arizona. Describe the event that produced this crater. It's a collision of asteroid, meteorite, or a comet. Base your answers questions 38 through 40 on the reading passage below in your knowledge of earth science. I need you guys to actually read that passage and then answer number 38 through 40. Explain why a blue moon never occurs during the month of February. Now, a blue moon is when you have two full moons in 1 month. And we know a complete lunar cycle is 29.5 days. February only has 28 days normally. So February is too short of a month. 39. What is the greatest number of full moon phases visible from Earth that is possible in a span of 1 year? So if you figure it out mathematically and you had 2 in January, the most that you could have possibly is 13 a year. Number 40. Draw the relative positions of the Earth, the moon, and the sun as viewed from space so that a full moon phase would be visible to an observer on Earth. Label the Earth, the moon, and the sun in your drawing. I have sun, Earth, moon. Base your answers to question 41, 42 on the information below in your knowledge of earth science. An accurate observations of the sun were made by a New York State observer. The person observed the time of sunrise and position of sunrise along eastern horizon for each day during the month of May. 41. Describe how the time of sunrise changed for the observer each day during the month of May. So if you're looking at it, you're going back to that one diagram. The sunrise is going to rise a little earlier each day. So for us, right now in May, we've been increasing our daylight about a minute or two a day since December. 42. State the actual Earth motion that causes the sun to appear to rise each day. That's because the Earth is rotating, so rotation. Base your answers question 43 through 45 on the diagram provided below in your knowledge of earth science. Diagram shows the sun, Earth, and the moon's orbit around the Earth as viewed from space. 43. On the diagram above, draw a circle of approximately this size to represent the moon's position in its orbit when a solar eclipse is viewed from Earth. solar eclipse, I need a new moon. So I need to have the sun, the moon, and the earth perfectly aligned. 44. Approximately how many complete revolutions does the moon make around the earth each month? Alright, since the month is based on one complete revolution of the moon around the earth, the answer is 1. 45. Explain why solar eclipses do not occur every time the moon revolves around the earth. The moon and the earth orbits aren't always in the same plane, so they're usually off by 5 degrees, so they're not perfectly aligned. Base your answers to question 46 and 47 on the data table below, which provides information about 4 of Jupiter's moons. 46. Identify the planet in our solar system that is closest diameter of Calypso. So if I'm looking at the size of it, we're looking at 4,800 kilometers. I need to go back to your reference table, page 15. So we're looking at size. Equatorial diameter. The one that's closest to 4,800 is going to be Mercury. In 1610, Galileo was the first person to observe with the aid of a telescope these 4 moons orbiting Jupiter. Explain why Galileo's observation of this motion did not support the geocentric model of our solar system. It didn't support the geocentric because geocentric, the moons would be revolving around the Earth and not Jupiter. So moons were orbiting Jupiter and not the Earth. Hope this helps. Good luck.